Hello students, welcome to the course on Hydropower Engineering GEH 301 offered to students of Engineering Geology program during 5th semester. I'm Kirtan Adhikari, faculty at College of Science and Technology, Royal University of Bhutan. Welcome students. The first unit of this course is Introduction to Hydropower Plant. In this unit, we will be studying the sources and different forms of energy, types of hydropower plants. We'll be studying various components of a hydropower plant. Further, we shall discuss hydropower sector in Bhutan. And finally, we shall see the structural aspect of powerhouse. As we all have studied in our physics and chemistry classes that energy exists in various forms. We also know that energy from fossil fuel drives a vehicle. If we place an ice cube on a table, it melts because the heat energy from its surrounding acts upon it and raises its temperature, thereby melting it. Likewise, there are plenty of other forms of energy as you can see from this diagram. However, we shall focus on electrical energy that too extracted from flowing water. You can notice from this small icon that electrical energy is connected to dollar, emphasizing money. In fact, it is one of the forms that would be consumed. It would be consumed more in the future, as electrical energy is clean without any emissions. As effort to mitigate climate change is greatly emphasized globally, there is a huge demand for clean energy, and which is the electrical energy. There are plenty of ways to generate electrical energy. However, all these methods are not viable at all the places. Along the ocean shore, tide can be utilized to generate electrical energy. Likewise, in Bhutan, we can utilize the kinetic energy of flowing water to generate electricity, and this way of generating electricity is known as hydropower electricity. Throughout this course, we shall be only discussing hydropower energy. Let's continue our discussion with the energy. So, what exactly is energy? Technically, it is defined as the capacity to do work. When an object gets displaced, some energy is used up, or we say some energy is required to displace an object. Energy is in fact measured indirectly. There is no instrument as such that can measure energy like we measure other physical quantities. Energy is correlated to amount of work done. Here, work is defined as the force multiplied by the displacement. And the unit of energy is joules. Like I said, work done technically is the force applied times the displacement of that object. Now we know that force is measured in Newton and displacement in meter. So joule is in fact Newton meter. The next parameter that we also need to discuss is the power. The amount of work done in a given duration is known as power. So technically, power is work done by time. And the electrical energy is measured in kilowatt hour. It is the kilowatt energy spent during a period of 1 hour. Next topic we have is the conversion of other forms of energy to electrical energy. The question is why we need to convert to electricity. The simplest answer to it is we consume electrical energy the most. Look around. All Almost all the appliances runs with electricity. The Tesla company, owned by Elon Musk, have achieved new heights to drive automobiles with electricity. It can be foreseen that electricity would be the dominant form of energy for mankind in times to come. That's why we convert other forms of energy to electrical energy. The conversion is based on law of conservation of energy, which states that energy can neither be created nor it can be destroyed, but it can be converted or transformed from one form to another. But we need to understand that when the conversion happens, there's always a loss associated with it. Let's see how fossil fuel, mostly the coal and natural gas, is converted into electrical energy. In fact, it is very straightforward. The fuel is burned in a furnace. The heat energy is used to heat the water, and the pressurized steam runs the turbine, which in turns drive the generator, and electricity is produced. According to the latest world energy statistics, non-renewable sources is dominant. However, there's a great effort towards replacing these non-renewable resources with renewable sources. Okay, we should be very proud that majority of energy sources are renewable in Bhutan. Next, in a similar way, the wind energy is utilized to generate electricity. When the heat energy from the sun hits the land surface, which heats the atmosphere above it, the heated air mass starts to rise, thereby creating a region of high pressure and low pressure. And we know that wind blows from higher pressure to lower pressure region. You may have noticed that in mountainous region, usually it is windy during afternoon. This is because during the morning, the above said phenomenon gets initiated. When the wind blows, it rotates the blade of the turbine, of the wind turbine, and the electricity is thus generated. These are the two wind turbines installed in Wangdi. Please make a visit to this site if you ever travel to Wangdi. In fact, it is visible from the roadside if you ever travel from Thimphu to Dagana or Tsirang, or even if you travel to Eastern Dzongkaks, you can see this two installed wind turbines from the Wangdi bridge. And the next is, I'm pretty sure that all of you are aware of solar panels. It uses the solar radiation to generate electricity. The solar panels are also installed in the roof of survey lab. As a case study, you can interview Mr. Namge Tenzin, Faculty of Electrical Department, to know more about the solar panels installed in CST. And finally, we have the hydropower energy. Just like the case of wind energy, the sun drives the water cycle. Water from ocean gets evaporated and forms cloud. These cloud carries huge water and drops it in the form of precipitation and flows back to ocean as a river and stream. Usually dams are constructed across the river and water is utilized to generate hydropower electricity. During this course, we'll be focusing on how water is utilized to generate electricity. With this, I would like to end my first lecture. Thank you.